right, let's check out T44, which is the mean value theorem. It's the second kind of existence theorem that we are going to talk about. And remember, when you learn those, you need to learn the conditions. Like, you've got to know when it holds, so what conditions have to be met, and what the conclusion is and how to use it. So the conditions of the mean value theorem are this. The conditions are f is continuous on the closed. I need a thinner pen, too thick. And differentiable on the open. So those two things, we have to have a continuous function on the closed interval, and it has to be differentiable on the open. Then what is the conclusion? Well, this picture kind of shows what the conclusion is, but let's just see if we can figure it out. What I'm saying is that somewhere that the slope, if I found the slope of the secant line, so the slope of that blue line, somewhere in between A and B, there has to be a place where the slope of the tangent line is the same as the slope of the secant line. Now, obviously in this picture, I actually have three different places, but the theorem says that there must be at least one. So let's see how to write that mathematically. If you have a f is continuous on the closed and differentiable on the open, then f prime at C has to equal, that's the slope of the tangent line at C, has to equal the slope of the secant line, which would be f of B minus f of A over B minus A, for at least one C in the interval A to B. Now notice in this one, it cannot be an endpoint. So for like IVT, these were closed right here, but for this, it is open. And so again, with mean value theorem, I tend to remember words because formulas, I'm like, okay, there's so many and I forget. The mean value theorem for derivatives is that the slope of the tangent line at some point must equal the slope of the secant line. Or I could say it another way in things that we've talked about. At some point, the instantaneous rate of change, I'm going to abbreviate, is equal to the average rate of change. So let's work a problem and we will see how we use that formula. It says, verify that f of x satisfy the conditions of the mean value theorem on the interval 2 to 4. Now remember, when you're using these, unless the question says using the definition of continuity, you don't have to use that, but you have to state it. So can you see that f is continuous from 2 to 4? Well, where it would be discontinuous would be at 0, but luckily my interval is good, so I can just state f of x is continuous on 2 to 4. Now, do you know it's differentiable? If you have a problem, if you're like, gosh, I don't know, is it differentiable or is it not? Think about, go ahead and find the derivative. I could write f of x as 5x to the negative, 5 minus 4x to the negative 1. So would you agree that f prime would be equal to, if I did the power rule, 4x to the negative 2, or in other words, 4 over x squared? Well, if you look at that derivative, then that derivative is not differentiable at 0, which I'm still okay because of the 2 to 4. So, and f of x is differentiable on the open. So I have stated that, therefore Thus, the MVT applies. So you always need to look for the conditions. Now, it says once I've verified that it does apply, it says find the value of C that satisfies the conclusion. So remember, what is the value of C? Looking at the picture, there's some x value, C, that the slope of the tangent line at C is equal to the slope of the secant line. So I personally find the slope of the secant line first. So if my interval is 2 to 4, I'm going to find f of 2 and f of 4. And again, you can do that on your head. You don't have to show how you get that, but I notice I do have it labeled. So f of 2, if I plug in 2 right there, that's 5 minus 2, so that's 3. If I plug in 4, that's 5 minus 1, that would be 4. So the slope of the secant line is going to be, if I find the slope of the secant line, so I'm doing the f of b minus f of a over b minus a, I end up getting 1/2. So the slope of the secant line is 1/2. So what does the mean value theorem say? There has to be some place where the slope of the tangent line, and that's the thing where you're not doing too much work when you find this derivative, because you have to find that anyway. So you're saying that 4 minus x squared, I'm trying to find where the slope of the tangent line is equal to the slope of the secant line. So I'm going to put that in. Now notice you say, what about the c's? I always solve it with x first. So I get x squared is equal to 8. Now if I were just solving, and this was an algebra problem, I would get plus or minus square root of 8. But remember, it says find the value of c that satisfies the conclusion. Remember that our interval is 2 to 4. So the only c value is the square root of 8. The negative would not be in that interval. And so the c value is square root of 8. Now I want to be very clear of that's the answer, but you're like, okay, what am I saying? What you're saying is, if I were to draw this graph right here, and if I found the derivative at square root of 8, it would be equal to the slope of the secant line, which was 1/2. Okay, the secant line on that particular interval. That's what it's saying. Okay? So that's how you use the MVT for derivatives. Now the next side is really just emphasizing conditions. It says, do the following satisfy the conditions of the MVT over the interval a to b? If not, state the condition that is not met. So if you look at that picture, this first one, I want you to see if you can write that on your, remember there are two conditions, so that's what you're looking at. So see if you can write and see if they're satisfied. So this top one, are the conditions met? Nope. F of x, we'll just call all those f of x. F of x is not differentiable over that whole interval, because notice right here, at this point right there, the derivative from the left is not the same as the derivative from the right, so it would not be differentiable at that point, so the MVT would not apply. The second one, do we have a continuous function? Yep. Do we have a differentiable function? Yep. So this guy is a yes. The MVT applies. Now I didn't ask this, okay, but just to reiterate, so what would that mean? It would mean if I found the slope of this secant line, that green line, I can promise you somewhere between A and B, the slope of a tangent line, I'll approximate, maybe about right there. There's one. There's probably another one over here. So there's actually two. Okay? At least once, the slope of the tangent line at a particular point is going to be equal to the slope of that secant line. And finally, that last one, would the MVT apply there? Nope, because y, f of x, is not continuous on the closed. So from A to B, notice it has to be continuous even at the endpoints, and I don't have that, so my function is not, does not satisfy the conditions of the MVT. All right. Now I want to warn you on your homework. There's one problem that, the one that I solved when we were solving this problem where you had, the 4 over x squared is equal to whatever it was, 1/2. That was very easy to be done algebraically. You need to solve yours algebraically because that certainly could be on a non-calculator part. I will tell you that number 3 on the homework, I do not expect you to know that number and be able to do that one without a calculator to get the decimal. So you can use a calculator on that guy. But the rest of them you should be able to do without a calculator. All right, well, good luck doing the MVT. Peace out.